I just want to talk a little bit about how to deal with data, um, in a different way than you might be used to dealing with data. And that's where Bitfields comes in. I'm just gonna make a file called bits.c. Looks like I was already starting to do that before. So let's make it. And it looks like it works to me. All right, so we just built a make file and just some basic kind of boilerplate out of the way. Now, in order to work, to really display like a bit field, I think we should use the stdinst library. So that gives us like uint 16, uint 32. So let's all right, so we have different variables that are different sizes. Here I can display that. I don't like this color scheme either. What did I do? L forward? I guess that looks a little better. Yeah, that looks better. So if I do a printf, and I do the size of each one, size of 8-bit, right? It should say 8. Well, it should say 2, because it should be 2 bytes, and there's 4 bits in a byte. So if I just make and bits and run it, oh, we have an issue. Unsigned long int, and that's an int. But it shows 1 unsigned long. I'll just do ul right there. Boom. It shows. Actually, it would be lu, I think, not ul. Because the long is l. Is it lu? I don't know. We'll see. Yeah. Anyways, it shows it size of 8-bit being 1. Oh yeah, that's right. Because there's 8 bits to every byte. I think I said 4 earlier for some reason. Sorry if I did. So, okay, well. You notice 8-bit is 1 byte. 16-bit is 2 bytes. That's 8 times 2. 32 is 4. 8 times 4 is 32. 64 is 8. 8 times 8 is 64. So if you want to make a bit field, one of the simplest things you can do is kind of like make flags. I'm going to get speed crunch out here to like kind of display this. So if we have 8 bits, that's 0 through 7 right here, from left to right, right? If we want to make like different flags for things, you could do something like this. So let's do this. Do set is drivable for A. So then I can print back these values. So there we go. It says it is drivable and it is running. And if we check this, what we set here earlier, we set that it's drivable and we set that it's running. So yeah, those flags are set correctly. So now that I kind of went through making this, I want to go through a little bit of explaining like what exactly is going on. So what did I do here? The set is drivable right here. So if I had to explain what's happening, here's this 8-bit, right? I initialized all these to 0 because you really want to do that first, just so you don't get some random garbage values there. I'm pretty sure C might already do that, but it's a good safety to just do that anyways, so you know it's going to be 0. Because if I didn't set it to 0, right, there might be some random bits in there, like it's uninitialized, right, that I don't know about. That could have been used for some other type of data in some other program or something. But anyways, let's do this is drivable right here, right? So what's happening here? Well, A is for A. It looks like I put our variable 8-bit, and then I put a boolean here, which is just one or 0, true or false. True is 1, false is 0. So we got A, which is all zeros. It's just literally 8 zeros. And to make it look a little more easier to look at, I'm going to separate 4 bits at a time like that. So we have this is our variable A right now. Before we put it to the set is drivable macro, right? This is what it looks like. And then what we're doing is we're saying, oh, okay, so we're doing an OR. So that's an OR is if either of the values are 1, right? Either of them, then we're going to assign it. We're going to set that bit as 1 if the value on the right side of the right side, if a bit on the right side is 1, then it'll be applied to A, to a bit on A on the left side of the operand. So any bits on the right operand that are 1 will be applied to the bits on the left side of the operand. I'm going to explain that one more time because I want to make it make sense. So the bits on the right side of the operand, any bits that are 1 will be applied to the bits on the left side of the operand. Okay, I think I said it right. So there we go. So right now we have B, right? B we set is just literally 1. That's all it is. So we know that the value right there, what is the value of 1 in binary? 1. What is the value of 0 in binary? All 0. So that's just zeros, 1, it's 7 zeros and 1 1. So that's all we got to do here. 7 zeros, 1 1. So this is B. That's getting put. This is what the values look like in the parameters right here, right? Before going through this. So then what happens to this is it says, take this A, right? I'm just going to copy and paste. So this is in parameters before manipulated, right? And then I'll do values of parameters before being then param. So A applies an OR operation to B, but B if B is greater than 0. B if GT greater than 0. And B is greater than 0, so we're going to apply our OR. So it looks like, okay, well, the only thing, so this bit is 0 and this bit is 0, so guess what? The output, because it's an OR equals, right? The output is going to be A, what A equals. So in this section right here, we got a 1 and a 0, so that's a 1. We got a 0 to 0, that's a 0. 0 to 0, it's a 0, 0, 0. Guess what? It's a 0. These are all 0, so they're zeros. So the output, the result from all this is A is now equal to 0. Because, and it is greater than 0. Now let's look at what's happening in is affordable, okay? So a lot of the same stuff is kind of already happening, but this time we've already applied the bit from is, like I'm going in order, so we just did this is drivable, what about is affordable, right? I'm not going to do all these because that would take a long time, but so now we already set the parameter for is drivable, let's do it. Let's go down as if it's reading the code. We're going to is affordable. So what happens here? So the value of A we already know, set before was actually this. The value of B is false, so it's all zeros. Then the parameters being manipulated. A we know is 1, and then if greater than 0, then we apply 1, and then if it's not greater than 0, let's do B if not greater than 0. If not, then B is 0 if not greater than 0. So we know that now B is 0, but it's pushing that bit 1 to the left. So not a whole lot is happening here, right? So A, let's get the result of A, because it's applying it to A again with OR equals. So we're going to ignore this right here. We're just going to focus on these two right here. So this and this. So 1 and 0, what does that equal? 1. I mean, well, we know one of these is a 1, so it's 1. And these are both 0, so this is 0, 0, both 0, both 0, and so on. Now, I'm going to go down one more into is running, and that'll be the last one I do. I pretty much actually already almost did all of them. But, so let's go down to is running and see what happens here with the bits. We already know A, this is the output of A will stay the same right here. The values for being manipulated. The value of B is actually true, so it's going to be 1. And then, boom. Yeah, so they're both actually 1. Didn't realize that until just now. There's a little bit of difference here that you'll see. Oh, and then, I forgot to mention, even though it applied this, it's, so when I got this result for B, it shifted it. This is 0, and it takes B, moves right 1 bit. So it took the 0 and it moved it to the right 1 bit. So it took the 0 that was already in this bit and it moved it to this bit, which doesn't make any difference at all. So that's what happened right here. And then after that happened, it made B still equal to the same thing because it was already 0, and then we got the A result. Okay, back to here. So we got A is 1. After we did is drivable and is affordable, we have A as being 1, and then we have B as being true, which is 1. Then parameters being manipulated. We have A is applying an OR value to B, but B is going to be 1 if it's greater than 0, and then also it's going to be 0 if it's greater than 0, and it's 1 because it's greater than 0. So we're going to take this, and we're going to know it's 1, and then we're going to move it to the right. Then, so let me just move to right 1 bit. So now it becomes this. And then after B was moved to the right, we apply that OR again. So we're going to compare what B is to what A is. So A is 1, B is 1. I mean, A is 1, and then B is 0. There's 1 there out of the two. So this one's 0, this one's 1, so we do 1. The rest are zeros. So once we do is running, we get this result for A. I'm not going to do these repairs because I hope by this point you understand what's happening. We're going to shift to the right 2 bits because of the 2. Shift to the right 2 bits right here. My bad. So this is actually going to be right here. So this is going to be 0, and this is going to be 1. Right? So this is 1, this is 0, this is 1, 0, 0, 0, 1. I mean 0, 1, 1. The rest of these are 0. So this is going to be the result after is running is applied. And then with the masks, what's happening here is in the is drivable is we're just literally doing and. We're just going to see, we're taking A and then seeing if some bit exists. So 0x01 is 1, and whatever is 1, all the 1s, right? Any so it's going to take A, let's say A is 5, and if I do and 0x01, it'll say, oh, that bit does exist in 5, that bit. See, that 5 has that first bit. So it just takes to see, it basically sees to see if both bits are equal to 1, then it returns, if both bits are equal to 1, then it applies the final result to 1. And if they're not, then it'll be 0. So so A, when it reaches here, let's say it's, we already know this is false, so I already know it's going to be this. Oops, so A is going to be this value right here, and then we're going to take A, B, take the value of A and compare it to this value, which is just 1. And say, hey, does this bit exist? This is our mask. And if both are 1, then we get a 1. Boom. So it is drivable. That bit is on, so it's true. And then we're going to do the same thing. It's for is affordable, except for the bits. So here, it's right here. And we see that none of these are both 1, so is affordable is false because, yeah, none of them are either the mask or the value that we put in the parameter. The bits on, none of the bits in the same positions are equal to 1. Okay. So now I'm going to go on to something a little bit different. I'm going to go on to, so that was a little more simple. That was like flags. All right, so now I'm going to go on to flags. No, I already did flags. I'm going to move on to something a little different, which is like storing data in different parts of the bit field. So let's move on to like the 16-bit thing right here. So let's say, for example, okay, I keep changing the color schemes. Let's say, for example, this. So I have 16 bits. So those are my 16 bits. I just kind of split them up into like 4 chunks. Let's say I just wanted these 4 bits to be one value from, and these 8 bits to be a whole another value, and then this last 4 bits to represent a different number. Now so I'm going to split it up like this. So value 1 is going to be, I'll do B1, B2, B3, right? So that's how it's kind of split up, right? Now, with it being split up like this, just to make it a little more understandable to look at, I guess. So with the bits, these 16 bits. So if I did 2 to the power of 16 minus 1. So these are our 16 bits that we'd have to work with right here. And we know these 0 through 3 is one value, 4 through 11 is another value, 12 through 15 is a different value. With 0 through 3, that's 4 bits, so 2 to the power of 4 minus 1 gives us values from 0 to 15 are the values that we can do for the first variable or whatever. For 2, there's 8 bits, so it's 2 to the power of 8 minus 1. It's 0 to 255. And then for the last one, we already know it's 0 through 15. Those are the possible values that we can do for the last 4 bits. So this is the number of bits we have. I just made them 0 because it's going to initialize to 0. And these are the variables, v1, v2, v3. And this is the amount of numbers that we can fit into these bits. Number ranges from 0 to 15 for the first one, 0 to 255 for the second, 0 to 15 for the third. Now, what you'll obviously come to realize is that this is the second v2, right? You notice that the highest number is 480, but that's counting these bits right here. And we don't want to count those first 4 bits because they're different values. So what we'll have to do is when we get the value out, we're going to have to shift it back 4 to get what we actually need. And I'll show you how to do that. So let's make the first value of the bit field. Fine. Let's do power level. I don't know. Set power level. And we're going to do A again. So we'll just do something simple. A and then 0x ff. So that'll be ff is x for the first. Actually, we want the first 4, so it's just f. 0x f. Yeah, so that's just the first bit. So I'm saying we're going to set the power level. So A. So if I did, it's 0 through 15. So if I did 4 and 15, it's still equal to 4, but I kind of make sure that I don't go over that. So if I did like 16, right? It's kind of like creating a barrier so that if it's greater than 15, that won't work. See, 15 works. 16, nope. 0, obviously it's going to work. But anything greater than 15 is not going to work. It's kind of saying is, in a way, it's like saying 3 as long as 3 is less than 15. So, but then I also want to do and equals. So I want to set it equal to that value. Oh wait, other way. A and. No, I don't want to do that. A equals or equals. Yeah, there we go. But yeah, so the mask right there is just to make sure it doesn't go above that value. So power level can be from 0 to 15. So I'm just writing this down. V1 power level. And then V2 might be, let's say it's a superhero. So power level V2 might be people saved. Set people saved. And this mask is going to be a little bit different. It's going to be from 4 to 11, right? Those are the values we decided. So honestly, what I do is I just use SpeedCrunch. I just highlight all the values, right? And that's 0x ff0. I kind of already, not going to lie, I mean, that's the best way to kind of like go about figuring out. So basically, this is the mask I want because I only want these values, 0x ff. But what I'm going to have to do is take the value of A, bit shift it to the right because look, we have this gap. So we want to take away this gap. We're going to have to bit shift it to the right 4. So bit shift it to the right 4. And I guess we might as well create that mask for just to be safe. Just to make sure we're not going over. So yeah, so A. Oh wait, what did I do here? Set power level. I never set the what I could set it to. Level B. So A is our bit field. B is the value you want to set it to. So this will be B. A equals B. We shift to the right 4. And we want to make sure. We also want to make sure that so A equals B, but shift to the right 4, and then apply that mask to make sure that we don't have any extra values or extra bits outside of those ranges going through, because that would cause problems with the other values we need to set. The last one could be, I don't know, set power level 0 to 15 is kind of low. I thought I'd think about it. Oh well, set height 15 feet is pretty tall, but whatever. Same process here, except kind of we know that height is those last 4 bits, so we want to shift it by 11. So you notice there's 11 here too. That's a good indicator to figure that out too. I mean there's 12 here. We actually want to shift it by 12 because shift this. Shift by 15, 12. Yep. And then we want to apply a different mask here, and I think that's 0xf000. I believe 0xf000. Yep. There's 3 zeros, so yeah. Bada bing, bada boom. And that should be all there is to it for setting that bit field 16-bit. So let's do that. So let's do set power level for 16-bit. I'm going to set it to 12. Kind of weak power level, but I don't. We're going to set people saved. Let's do the highest number we can do, 255. Oh, I didn't put a B in here. B. There we go. And then set height. That's making him 12 feet high. He's pretty tall, but not the max height. Alright, so now I gotta get these values, right? So I'm just gonna replace the S to a G, get power level. So we do A, we don't need the B, obviously, at this point. A, and we're just gonna apply our mask, which is this, 0xf. That'll get our value. And then for people saved, that's our mask. But we're gonna have to do a little bit of trickery here too. 0xff, 0, so I apply the mask first, and then because there's that offset of the 4 bits to the right, we're gonna have to bit shift it to the right 4. And then for the height, pretty similar stuff. We're gonna do the mask again for the last 4 bits, and 0xf 000, and then we're gonna bit shift it by the right 12 to make up for that the blank values. Just to show you that's the case. Yeah, that puts it back where it should be. So let's get these values that we set. So let's do power level. Those auto closing parentheses are not helpful in this situation. So let's do people saved, and then height. So we know 12, 20, 12, 255, and 12 should be our values that are output. This. Let's see what we get. 12, 255, and 12. So power level 12, save people saved, 255, height 12. And just to like show you that's actually working, let's do people saved 200. Boom. Same thing. And instead of using, so I'm making the most use of this variable by making a bit field in this way. Yeah, I don't think there's really anything else I want to show in this video. I think that's all. Hopefully you learned about more about how to use bit fields and how to store data in very tight spaces. You don't have a lot of memory to begin with. All right, thank you for watching. See you next time.